Welcome to lesson 4 of my basic differentiation course to give you an introduction to calculus. Now again, this course serves to give you the foundation that is relevant for you to be successful in any upcoming calculus course. So we're going through the basic techniques and the basic ideas with the intention to give you the foundation that is needed. We'll be going through very slowly, and we're going to make sure that all these fundamental points are well laid. Alright, so let's get started. So we're going to be looking at the definition as we have before. We know that the derivative of the function from what we've been doing in lesson 1 through 3 is given that the limit is as h tends to 0 of f of x plus h minus f of x all divided by h. Now we're going to be looking at the different notations. For the different notations, we recognize that y equal f of x, which is my original function. The derivative of that function can be written as f prime of x, y prime, or dy by dx, or d by dx of f of x. In all cases, these here are what is used to represent the derivative of a function of x, a function of x. Now, what we're going to be doing now, we're going to be going through the different techniques. We're going to make a transition from the definition now to the basic algebraic techniques that is used. So before we start to jump into that, we're going to go over some basic theorems that is used to differentiate these functions. So the first thing right here, we got y equal to f of x equal to c. Then we know that the derivative of x is equal to 0. Also, y prime equal to 0 suggests that dy by d of x is equal to 0. And this is very straightforward. If I have f of x equal to 10 pi squared, notice this is a fancy constant. Look a little bit complicated, but relatively simple, straightforward. Pi is approximately 3.14. So once I'm differentiating anything with a constant, the result gonna simply be equal to 0. So f prime of x here constant. So keep it going. So we're going to look now at theorem 2. Now theorem 1 is simply if I have a constant and I differentiate it, again the rate of change of a constant never changes, going to be 0. Now we're going to be looking at power rule with some basics right here. Looking at power rule with these basics, I know that f of prime of x, if I have f of x to be equal to x to n, going to simply be n in front times x to n minus 1. Again, in a parallel notation, I can write y prime is equal to n times x to n minus 1, or dy by dx equal to n times x to n minus 1. So a simple application right here, if I have f of x equal to x to 6, I know that my f of prime x simply going to be equal to 6 times x to 6 minus 1. Now again, very basic. We're trying to understand everything to make sure it is well laid. So we're going through slowly and building up the concepts. So with that being the case, our result then going to simply be 6x to 5. And that is the derivative of a function looking like this using the basic power rule. Alright, let's try this other example. Now, if you look at this example as is, it is not in the format that we would like it to be, where we have x to n to some number. So what we're going to do, we always try to get that into correct format first. To get that into the correct format first, I'm going to write f of x equal to, if I remember, if I have a to negative m, this is equal to 1 over a to m. So to write it in the appropriate format, we need to write it looking like this. This is going to be x to negative 5. Now if that is x to negative 5, the derivative of that going to simply be negative 5x to negative 5 minus 1. So my result here going to be negative 5x to negative 6, and that represents my derivative of this function. It's pretty straightforward there once we understand how to use the power rule. Alright, let's look at this second example. Now again, this example looks a little bit more daunting. All we need to do is remember our basics. And to remember our basics, just remember we're going to have x. Here we got 4. Now if you remember, if I have n divided by the square root of the nth root of x to m, this can be written as x. Now the n here, the root, the nth root, going to be at the bottom, so this is going to be m over n. Now to do that, I'm going to do the same thing with this example, f of prime x. We're not finding the derivative just yet, so let me just erase that. We're going to have x to 3 over 4. Now to find the derivative, what we're going to simply do, we're going to put that 3 over 4 down, so that's 3 over 4, and this is going to be x 3 over 4 minus 1. So that's the rule. Now mere simplification, this is going to be 3 over 4 x, this is going to be negative a quarter, or negative 1/4. That being the case, we're going to have 3 over 4 times 1 over x to 1/4. We know that because we can bring that down. And then using the rule above, this is going to be 3 times 1 over 4 times x to 1/4. Now notice we can put our 3 on the top, then we're going to have a 4. Doing the reverse, since that's in the denominator, that's going to be the 4th root of x, and this is my result for that example. So very closely, just make sure you go through these examples and follow what we're doing by using the power rule. Now let's keep it going. What we're going to be looking at now, we're going to be looking at the third theorem, and the theorem is working with multiples. If you have a constant multiple in front of the function, it is simply multiplying the constant by the result that you would have before. So you just find the derivative of the function and you multiply it by the constant. So technically the constant doesn't really change much. It's just going to be something there that you're going to be multiplying by the final result. So doing the derivative of this, we have x prime here. This is in a nice format for us already. That's going to be 4 times 12, because this 12 remains as is. X to 4 minus 1, that's going to be 48 times x to 3, and then that's going to complete that problem right there. So that's it in terms of using the constant and using the theorem. Pretty straightforward once you understand this. Just remember, you're going to simply multiply 4 times what is already there and then subtract 1. Now we're going to increase the difficulty just a little bit. We're going to look at the sum and difference property. For the sum and difference property is simply a case where we're adding two functions or subtracting two functions. The rules are very similar. It doesn't change much. All we're going to do is differentiate each part separately, and then we're going to add it or subtract it depending on the situation. So if I have to differentiate this using the power rule, we're going to do 3 times that 3 that is already there, x to 3 minus 1, plus 11 times 2 to x to 2 minus 1. This result here going to be 9x to 2 plus 22 times x to 1, which is just x. So as a result, this here going to be my answer for this. So just remember, if we're adding or subtracting, you just differentiate as is and just add and subtract at the end with the different functions that we're working with. So that completes that problem. So let's look at a problem like this. This problem is a little bit different. We want to find the derivative. So we got 3 minus x cubed all divided by 6. Now a problem like this, we're going to learn different techniques that can be used to differentiate this. But as is, we want to differentiate with the techniques that we have been taught before. So to do that, I realized that I could break this as two different fractions by dividing each of these by x to 6. And if I divide by x to 6, this 3 and this 6 is going to reduce to x to the 3rd right here. Now if that is x to the 3rd, I'm going to fix this up in a format where I can differentiate. So bring that up. Please recall, If you got a to negative m, this is the same thing as 1 over a to m. So using that, I can rewrite these. So this here going to be 3 times x to negative 6 minus x to negative 3. Now, if that is my situation, now I can differentiate. To differentiate, I'm going to have negative 6 times 3, x to negative 6 minus 1, right? Then I'm going to have my minus there. Then I'm going to be multiplying it by negative 3 to x to minus 3 minus 1. This is going to give me negative 18 x to negative 7 plus 3x to minus 4. Then I'm going to rewrite this. This is going to be negative 18 over x to 7 plus 3 over x to 4. And that completes my answer. Pretty straightforward. We just want to make sure that we understand